All right, this is going to be the beginning of the notes for section 4.2, which is called least square regression. So the first part, and I think that probably just the easiest thing for you to do is just to take notes on your own paper. We're starting out with something that we have actually already done in 4.1. So this part is going to be a little bit familiar to you. I know it's been a while, and after Snowpocalypse, you may not remember all of it, but it's also should be very familiar because it goes all the way back to Algebra 1. So we're using this data table. And least squares regression is all about, remember I told you when we started 4.1 that the only kind of association that we're worried about, the only set of kind of correlation that we're worried about in this class is a linear correlation. And that's what we were doing in 4.1. Remember we did our linear regression in our calculator, and remember we turned on our stat diagnostics so that we could see how good our linear regression was. So a least squares regression is another piece of that. So we're using actually the same data that was in the previous chapter, and we are trying to find basically the line of best fit. So now the first thing that we're going to do is not finding the least squares regression, but it's just finding an equation of a line that we're going to call the line of best fit. So I have already put this data in my calculator just to kind of make this part a little bit faster. And instead of plotting this by hand. So you can put it in your calculator if you want to. You can just look at mine for right now because this part of it's actually just kind of a review of what we've already done, making a scatter plot. So I've turned on my stat plots. I've put the data in my two stat lists, and there they are in list 1 and list 2. So there's list 1, list 2. We're talking about golf clubs and how far, how fast, the effect of speed on the distance that you can drive a golf ball. So that's what this club head speed and the distance that you can drive is all about. So when I go to graph, and I've already hit zoom 9, and so these are the dots that I've put in. So we could draw on here what we would call our line of best fit. You know, it won't be very good because I can't use a ruler on here, but if I was just going to draw a line, I might draw it right there. I don't know. But if I need to come up with an equation for that line without using my calculator to do a linear regression, then what I'm going to do is I'm just going to choose two lines. So this is, let me clear my drawings here. I'm just going to choose two dots from my my data list. It doesn't matter which two you choose. So let's say I'll use, just because they're kind of, I'll use 103 and 274, and let's use 100 and 263. And you can see right here they've written them down as an XY pair. In my calculator, they're in my list 1 and list 2. They're an XY pair. So what we're going to do is we're just going to use, like 9th grade math, we're going to use the slope formula. So reminder of slope formula. Slope is y2 minus y1, change in y, over change in x. So we're going to just plug these in. It doesn't matter which one you call 0.1 and which one you call 0.2, but because this one's on top, I'll call it 0.1, and this one will be 0.2. So I'm going to do 263 minus 274 over 100 minus 103 to find my slope. That gives me negative 11 over negative 3. So 11 thirds. You'll see kind of a lot like, we've kind of talked about this before, but statistics is more of a science. It actually is a science. And a lot of times in science, as opposed to math, we want the decimal version of this. A mathematician would prefer to leave it as 11 over 3. I would prefer to leave it as 11 over 3 because it's not as messy. But because this is a science, we're going to go ahead and use the decimal version of 11 thirds. So if you're not good with that and you're not sure, you can always go plug it in your calculator and see what the decimal version is. So 11 divided by 3. 3.66666667. So just to make it easy, we'll use 3.67 as our slope. All right, so my slope, we're going to call it 3.67. And now we're going to use point slope form. Now you may not be as familiar with it because you don't use it in 9th grade as much, but I'll remind you of what it is. It's so simple to use. Y minus y1 equals m x minus x1. All right, now when I plug into this formula, I know that I used this as my x1, y1, but you don't have to stay with that. You can use, now you have to use one of those too, but you can use the other one if it's an easier point. It doesn't really matter in this case, but so I'll just stick with the one that I started with just to, I don't know, for uniformity, I guess. So let's do the ones that you're going to plug in. The y and the x stay the same, but the minus y1, that's going to be y minus 274 equals my slope, which we said was 3.67, x minus, and my x was 103. We do want to go ahead and simplify this and put it into slope-intercept form. So you need to get rid of your parentheses. So distribute your 3.67. So that's going to give me, let me erase the formula here since you probably know that already. All right, that's going to give me, let me get my pencil back. All right, so that's y minus 274 equals 3.67x minus, I'm going to do 3.67 times 3.67 times 103. Sorry, my handwriting is so bad. It's not as easy to write on this. All right, so that's 378.01. And then we just have to move the 274 over. So I'm going to add 274 to both sides. To get y by itself so that it's in slope-intercept form. And I end up with negative 104.01. So my line, what we're going to call the equation for our line of best fit is y equals 3.67x minus 104.01. All right, I'm going to stop this video right now. What we just did, we did not find the least squares regression yet. We just found our line of best fit. I'm going to stop this video and we're going to pick up again on another video. At least I think I am.